Hello, my amazing students, pre-algebra students. This is Mrs. A, and I love math. Today we're doing lesson 7, which is all about rates and average, measures of central tendency, and the first thing we have to do is learn what a rate is. A rate is a division relationship or a ratio of two measures. Remember, a ratio is the same thing as a fraction. Unit rates are special rates that have a 1 as the coefficient of the denominator unit. So, for example, if I said 60 miles per hour, that's the way we would normally give a rate of a car driving down a highway, wouldn't we? 65 miles per hour. And that hour down there has just a 1 there. So it's 65 miles every hour. We wouldn't say I'm going 130 miles every 2 hours. We want a unit rate because it's clearer. 32 feet per second. Okay, so here is going to be our pattern. The number of hours times 65 miles per hour gives us the number of miles. Now notice how we're using exactly what we did last couple of lessons here. Hours is on top. Hours is on bottom. Hours is going to cancel. And when I cancel out the units, like a little road map, it tells me where I'm going. Now I only have miles, therefore my answer is in miles. And that's what I wanted. Okay, so we have some examples. So remember that your examples that I'm showing you on the board are the examples in the book. They are also in your book packet. So the first example is example 1. So turn there in your book packet so that you can see and follow along with me. You should be taking notes in your notebook binder. Driving at an average speed of 55 miles per hour. About how far will the driver travel for 6 hours? Okay, so he's traveling for 6 hours and he's going 55 miles per hour. So here I have, oops, that's example 2. This is example 1. Okay, 55 miles per hour, 55 miles per 1 hour. That's what this means. Okay, so here's our ratio. 6 hours is how long we're driving. 55 miles per hour is the speed. Now look at the cool thing again. The hours is on the top, right? When there's not a fraction, that's in the numerator. So the hours cancels the hours, leaving you only with miles. Therefore, our answer is in miles, which is what we're looking for. 6 times 55. Okay, well, 55 times 6. 5 times 6 is 30. Carry my 3. 5 times 6 is 30 again. But I add the 3 and I get 33. So 330 miles will be how far this car travels if they travel for 6 hours at 55 miles per hour. Okay, so example 2 also has to do with these rates. Heather finished the 100-kilometer bike race in 4 hours. What was her average speed in kilometers per hour? So we have 100 kilometers in 4 hours. So we're looking for how many kilometers per hour. I'm going to start with 100 kilometers in 4 hours. And I'm going to simplify this fraction to get just 1 hour on the denominator. So I'm going to divide the numerator and the denominator by 4. I'm canceling out a 4 is what I'm doing. So 100 divided by 4 is 25, and 4 divided by 4 is 1 hour. So 25 kilometers per hour. Looking for the unit rate. 25 kilometers per hour. So you're basically just writing down this in a fraction form and simplifying it to get 1 in the denominator. That's all there is to it. Okay, example number 3. Looking in your book, example number 3 reads, traveling at an average rate of 58 miles per hour, about how long would it take a car to travel 20 miles? Okay, so 20 miles is how far we want to go, 58 miles per hour. We don't know the time. We do know that so many hours times 58 meters. Let's see, what was it? Miles, 58 miles per hour will give me the number of miles. I know that. Okay, so let's put what we know in there. So we know that we're going 20 miles. So that is known. We know that our hours will cancel hours. We don't know this. So we really want to do a division problem, don't we? We want to take 20 divided by 58. Because notice, we're going 58 miles per hour and we only need to go 20 miles. Are we going to go a whole hour? A whole hour would be 58 miles. We're going to go a part of an hour, aren't we? So to find out how many hours, we're going to go backwards. 20 divided by 58 will give me the number of. So this is what I'm looking for. 20 divided by 58, the hours cancel the hours, will give me the number, the part of an hour that we're going to go. So we're going to go 20 over 58 hours, which, if you are approximating, which your book is telling you to approximate, we're going to look at, say, 58 is really close to 60. 20 divided by 60 is 1/3. 1/3 of an hour is approximately 20 minutes. Okay, but since 58 isn't quite 60, then this makes this, remember, as our denominator goes smaller, the number goes bigger. So this is going to be a little bit greater than 20. So greater by a little bit, because the 58 is not quite the 60. Now, I looked in your book, and they never meant for you to do the math. They just said about. Now, your book did it a little bit differently. Your book estimated right here and said, well, 58 minutes is real close to 60. 58 miles is real close to 60 miles. 60 miles in an hour would be a mile every minute. And since we've got to go 20 miles, then it would be about 20 minutes. But that's not quite there, so it's going to be a little bit more than 20 minutes. They never wanted you to actually work out that problem. However, if you did get a calculator, you would take 20 over 58, that's in hours. Okay, you would multiply by 1 hour is 60 minutes, and you would grab your calculator and you would do it, and you would get a number that is just a little bit over 20. So let me grab my little calculator, which I happen to have right here, and we're going to do the math on the calculator since your book never wanted you to go and do that. Okay, so we're going to turn it on. I'm going to write 20 divided by 58 times the 60, and we get 20.689. So almost 21 minutes, because it's 0.689. We'll round it up. We'll say about 21 minutes. Now for the second part of this lesson, we're going to talk about average. Now, we did in one of our problems talk about the average speed, because the truck's not going to go exactly the same speed the entire time it's driving. But the average speed would be the speed that it would have traveled consistently to get to the destination in the amount of time given. So an average of a set of numbers is a central number, and that means it's in the middle of all the numbers. And to get that average, also called the mean, we will add all the items and divide by the number of items. So they have a cool picture in your book I want to show you. So right here, they have different amounts of coins in each stack. And they tell you here they have 1 in the first stack, 5, 3, 4, 2. Altogether, they have 15 coins. An average would be if we leveled all of those stacks and said, okay, I'm going to divide the 15 coins into the 5 stacks evenly, and then we would see that we would have 3 coins in each stack. So we would say there's an average of 3 coins in each stack. Pretty cool, huh? Okay, so looking at example 4, and read it with me in your book packets there, okay? In the 4 8th grade classrooms at Keeler School, there are 28, 29, 31, and 32 students. What is the average number of students in an 8th grade classroom at Keeler School? Okay, so we're going to add these together. Remember, our average formula is 28 plus 29 plus 31 plus 32 divided by the number of items that we have, which is 4. So we're going to add all of these up together. Now, we're going to 28 plus 29 is 57, and 31 plus 32 is 63. So when I add those together, I'm going to get 120. And then I'm going to divide by 4, which is going to tell me that there is an average of 30 students per 8th grade classroom. Okay, so I'd have to add 2 to this one, add 1 to that one, take away 1, take away 2. So it is 30, isn't it? To level out the classrooms, 30 in each gives us 120. Adding those up gives us 120. Okay, so let's talk about all of the measures of central tendency that we're going to study in this book. The average or the mean, which we just talked about. The median, which is the very middle number of the data set. To get the median, we line up all of the data from least to greatest, and then we pick the middle number by going dun, 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 on both sides. Or if we have 2 middle numbers, we take the average of those 2 middle numbers. So the median has a very special procedure. The mode is the most frequently occurring number. Okay, so these 3 we have to be familiar with. Now we're going to do a problem that is going to take us a minute because we're going to do all 3 of those in one problem. Okay, so let's look at example 5, and I'm going to read it to you first. It says, below, we show the prices of new homes sold in a certain neighborhood. Find the mean, median, and the mode of the data. Which measurement should be the researcher use to best represent the data? Okay, so the homes are priced in thousands, and they are listed here on my board. Okay, now I did a little bit of this work for you because I didn't want to take a lot of video time, but here are the 12 prices. And remember, these are all in thousands, so that's $170,000. And here is your 12 prices. I added them all for you. The sum of all of these up is 2,278. So to find the average, we would take 2,278 and divide by 12 because there were 12 items. And the average or the mean turns out to be 189.83, repeating, which is approximately $190,000, which is what your book said. Now we move to the median. For the median, we must put all of the prices in order from least to greatest. And your book has this done for you also. Once we get them all in order, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I ran out of room, then we're going to find the middle number. So here's the left one, okay, the next one, the next one. I'm moving into the middle, right? The next one, the next one, and then I have 2 that are in the middle. Since I have 2 that are in the middle, I have to take the average of those 2. So the median would be 186 because it's right in between 185 and 187. So 186 will be the median, okay, which is what your book says. Now, we're going to look for the mode. The mode of all these prices is the one that is in there the most times. It's always going to be easiest to see your mode if you will go ahead and put your numbers in least to greatest order. Another way to do that is to make a stem and leaf plot. That works very nicely. But this one right here is where we have, and it's only 2. Okay, so we had 2 that were 175,000. So our mode is 175 because that was the item that had the highest frequency. Okay, so now there's one more question that they ask here. They said, which of these 3 measures is going to be the best way to determine the true center of this data? Okay, so now remember, the mode was just the most common one. Okay, so if I said the center of this data was 175, when I have a whole bunch up here in the 200s, that would not have been very accurate. Just because this one is the one that was there twice doesn't mean it really is representative of all my data. Okay, now the mean in this case could be greatly influenced by a very low or a very high price. Usually when we're talking about something like prices, the mean is not going to be the best indication. I would go with the median, okay, because that truly is, when you line up all the points, that is truly the center of that data. So I'm going to read you what they write in your example. Okay, it says, if the researcher is reporting to someone interested in property tax revenue, the mean is a good statistic to report. It may be useful in predicting revenue from property taxes. However, if the researcher is reporting to prospective buyers, the median is a good statistic to report. It tells the buyer that half of the new homes cost less than $186,000. The mean may be misleading to a buyer. Its value is greater than the median because of a few expensive homes. Only 1/3 of the homes were sold for more than $90,000. Remember, $190,000 was the mean, and it was higher than most of the houses. So we would use the median to be the most accurate of those, okay? And the last term that your book wanted to cover was range. Now, range is really, when you get into higher math and statistics, is what we're talking about. Range is really a measure of dispersion, but your book is not going to get into dispersion. So range is pretty easy. It's the highest value minus the lowest value in any data set. So they just wanted you to be familiar. And they said that the range of house values in that last problem was $49,000. So there was quite a range in the values of the houses. So now we're going to start working on your practice set together. Okay, so the first problem in the book, the practice problem, Alba ran 21 miles in 3 hours. What was her average speed in miles per hour? Okay, so 21 miles in 3 hours. We want miles per hour. They gave us 21 miles in 3 hours. So first we write it that way, but we want a 1 in the denominator, not a 3. So we're going to divide the top and the bottom by 3 and get 7 miles per hour. And that is her average rate. Now let's look at the next one. It says, how far can Freddy drive in 8 hours at an average speed of 50 miles an hour? Okay, so we're going to say how far. So we're going to say how many miles. Okay, and Freddy is driving he's driving 8 hours at 50 miles per hour. Okay, so now we can always tell if we've set a problem up correctly by looking at our units. I'm looking for how far. I've got 8 hours. I've got 50 miles per hour. Won't hours cancel hours, leaving me with miles? And it looks like I have it set up correctly. So 8 times 50, 8 times 5 is 40. So I'm going to tack on another 0. And 400 miles is how far Freddy can drive in 8 hours. Okay, and C says, if a commuter train averages 62 miles per hour between stops that are 18 miles apart, about how many minutes does it take the train to travel the distance between the two stops? Okay, so that's a lot of words, but what are we looking for? The train is traveling at 62 miles per hour. It's going to go 18 miles before it hits the next stop. We're looking for how many minutes, not how many hours, because it's going 62 miles every hour, and we're only going 18 miles, right? So what would we do? We would start to get this in hours, and then we're going to move to minutes. Now, I've set this up for you. This is an excellent example of how your units are going to tell you if you're doing the problem correctly. We're going to start to go for hours, and then we're going to change those hours into minutes. But notice at the problem in the book, it says about how many. So this is one that they don't expect us to do exactly, because it would take us a lot of time. We would probably use a calculator on this one, and we're not going to, because we're just looking for about how many minutes. So 62 miles per hour, 18 miles. I'm going to travel 18 miles. Every hour that I travel is going to take me 62 miles. Notice how I used miles and miles to cancel, leaving me with hours. Okay, so I have 18 over 62 hours is the fraction of the hour we're going to take. But they want to know how many minutes. So I'm going to get another board here. Okay, so I have 18 over 62 hours, but I want minutes. So I'm going to multiply by 1 hour in the denominator, 60 minutes in the numerator. And my hours are going to cancel hours. Okay, now what they're wanting us to do is estimate. Isn't 62 and 60 really close to each other? So it's going to take 18 minutes-ish. Okay, now is it going to be, let's look, is it going to be greater than or less than 18 minutes? Okay, so we got 60 on the top, 62 on the bottom. Okay, when we canceled those, if we were doing exact math, we'd have a little bit more than 1 down here, wouldn't we? So 18 divided by a little bit more than 1 would mean less than 18 minutes. Okay, now, can I find the exact? I'm going to do it on my calculator, but exactly, where's my calculator? Oh, there it is. Okay, I would take my 18 and divide it by my 62 and multiply it by my 60, and I get 17.4 minutes, which is less than 18 minutes that we approximated. When you're waiting on a bus or a train in this case, trying to see, okay, how much time do I have to read the newspaper before I get to the next stop? Doesn't really matter whether you just think, oh, it's going to be less than 18 minutes or it's going to be 17.4 minutes. Okay, so we just needed an approximation, and doing it this way by just saying, okay, that's going to be just about a good cancel. It's going to take me about 18 minutes, a little bit less, to get to the next stop. That's all they wanted you to do. Okay, I want you to actually see problem D closely. Okay, so problem D is an ABCD choice problem. And in order to do problem D, we need to understand what an average is. Remember, an average is a number that is in the middle of a group of numbers. It must be in the middle. So there will always, unless all the numbers are the same, if there is a number lower than the average, there must also be a number higher than the average for the average to be what it is. So here in this problem, it says, if the average of students in 3 classrooms is 26, and one of the classrooms has 23 students, then which of the following must be true? Okay, now what did I just tell you? If there's a number in the stack that's below the average, there must also be a number that's above the average, okay? At least one classroom has fewer than 23 students. No, because 26 is the average. Let me show you what we have on the screen. The average is 26, and one of the classrooms has 23. So A cannot be right because it says that there has to be one more room that is below 23. We need something higher as a must, okay? B says at least one classroom has more than 23 students and less than 26 students. Well, it might, but that's not a must because 26 is our mean and it should be in the middle of the others, okay? So we must have one that's higher than 26. That's what we have to have. And that one is D. It says at least one classroom has more than 26 students. So the answer is D. That's the one that has to be true, okay? So let's go to the next one. Okay, problem E is not too bad. We have to add all of these numerals together and divide by the number there are. So 1, 2, 3, 4, we're going to divide by 4. And we're going to add. I'm just going to add horizontally. So I'm going to kind of do it the fast way I like to. 6 and 4 is 10, plus 4 more is 14. So I've got 14. I'm going to carry the 1 over here. 9, 9, 9. 9 times 3 is 27. And then another 9. Okay, so that's 36. So we have 364 divided by 4. 4 into 36 is 9. 91 is the mean or the average of those. Okay, more you practice, the faster you're going to get at these. Okay, in problem F, they give us 5 basketball player heights in centimeters, and we're to find the average, which means we're going to add them all up and divide by 1, 2, 3, 4, 5. So we know that 5 is going to be the divisor, and we have to add all of these up. So I'm going to go ahead and do that in a column because I think it'll be easiest for you to follow. Okay, here's my column, and I always look for groups of 10. 10 and 10. 10 and 10 is 20, so that makes it easy. Okay, now I have a lot bigger numbers, but I have 1, 2, 3 9s and 8 and 2. So I have 3 nines is 27 plus 10 is 37. So I'm going to put down my 7, carry my 3. 3, 4, 5, 6, 7, 8, 9. 970 is my sum. So I'm going to take 970 and put it back over here on my other board. And now 970 centimeters divided by 5. 5 goes into 9 one time. 1 times 5 is 5. 4, 7. 5 goes into 47 9 times. 9 to 5 is 45. Leaving me with a 2 down here and a 0 brought down. So 20 divided by 5 is 4. So 194 centimeters would be the average of those 5 basketball players' height. Okay, so this last problem has 3 parts, and I love finding easier ways to do problems. That's one of the things that just really makes me happy. So I looked at all of these numbers on problem set G in your practice. Let me see if I can get the shine off of the board a little bit. And I had this long string of numbers, and they wanted me to display the data on a line plot, which I'll do for you in a minute, and compute the mean, median, and the mode and the range of that data. And I'm looking at all those numbers, and I said, hard number, hard number, hard number. And I don't like to add hard numbers, but then I looked. 99, 49, 99, 40, 99, 49, 49, 99, 49. So, Mrs. A, in her little brain, said, you know what? I can do this a lot easier. So I said, 99 cents is only 1 cent from $1, and 1.49 is only 1 cent from $1.50. And each one was only 1 cent from a much easier number to add. So then I added up all of those numbers and I got 13. But then I said, well, each one of those 8 numbers was a penny less. So then I took 8 pennies away from $13 and I got $12.92. Okay, so then I decided this. I went ahead and averaged the $12.92. I divided $12.92 by 8 and I got the exact answer. Then I said, what if I had just averaged these? So I had 13 and I divided it by 8 and I got 1.625, which is correct because then remember, in the average, each one of these was a penny less. So I need to take 1 penny away from that average to make it equal that average. And remember that a penny is 0.01 when we write it as a decimal. And if I take the 1 away from the hundredths place here, won't I get what I was supposed to get there? That just really makes Mrs. A excited when I find exciting new ways to do things. So this right there is the average of all of those numbers. Add them all up and divide by the number of items that there are, which is 8, or you can recognize a pattern and discover a much easier way to add them up and then take away the 8 pennies that it was over extra. That's what I would do. And I like to do things like that. Okay, so let's look at this problem. It says in G, display the data in a line plot, which I'm going to come back and do in just a minute. In H, compute the mean, median, mode, and range. Okay, so I like to look at these over here instead of those over there because those have a bunch of numbers. Okay, so mean, we already figured out the mean. Okay, median is when we put all the numbers in order and find the number in the middle. Okay, so let's just look at this. I'm going to erase this right here because we don't need all that math now. So we have a 1 and a 1. So we have 1, 1, and then we have a 1.5 and a 1.5 and a 1.5. So we have 3 of those. So let's just do this. Let's make a little stem and leaf plot. 1, we have 2 of those. 1.5, we have 1, 2, 3 of them. 2, 2. In 2s, we have 2 of them. In 2.5s, we have 1 of them. And that's it. 1, 2, 3, 4, 5, 6, 7, 8. So now I have made a little stem and leaf plot out of my easier numbers instead of my harder numbers. So when I go back to find my median, I'm going to have to take 1 penny away from it so that it will represent this data instead of my easier data. Okay, so when we're trying to figure this out, we start with the lowest, we mark 1 off, we mark 1 off, we mark 1 off, we come up here, we mark 1 off, mark 1 off, mark 1 off, and then we have 2 right here that are on the 1.5 line. So 1.5 represents 1.49. So our median, or our middle point in our set of data is 1.49. Our mode is the one that's hit the most often. Isn't 1.5, which is also 1.49 in the real data. It's also our mode because there were 3 of the 1.49s in the set of data. So this is our median and our mode of that set of data. Now, how do we find the range? Okay, the range is the highest minus the lowest. Okay, well, we know that the lowest is 0.99, represented by our 1 over here. And then the highest was 2.49, represented by our 2.5. So let me ask you this. If I take 2.5 and subtract 1, I get 1.5. If I take 2.49 and subtract 0.99, don't I still get 1.5? So isn't 1.5 our range? Okay, so I enjoy making harder problems easier. That's one of the reasons I love math so much. So there's your little board. And the last problem says, Rudy computed the average price and predicted that he would usually have to pay $1.62 per pound of apples. Evaluate Rudy's prediction based on your analysis of the data. Okay, he would usually have to pay $1.62. Was $1.62 the mean? Yeah, it was. So I'd say Rudy's correct. Wouldn't you? Because this was our mean of the data. That was our average price of the apples. So 162 is what that would round to in 2 decimal places. And we usually use money in 2 decimal places, don't we? So let's look at the display of the line plot, which I'm going to show you in just a moment. And here is the line plot for G. All they're doing is putting 1. Notice they're rounding a little bit. You wouldn't want to put 0.99 on the line plot. 1, 1.5, 2, 2.5. And they're just putting X's for each one in the data set that is represented. That's all they had to do. So we are done very thoroughly covering your lesson. However, I am going to put some problems out there for you too and do part of your homework for you if you want to watch that at home. So you can always pick up this video. It's on your Teams, and you can just click on it and see me do some of the problems for you. It's a big deal. This is Mrs. A, and may God bless your day. Okay, problem number 1 says, in the act, there were 12 clowns in each little car. If there were 132 clowns, how many little cars were there? Okay, so we have 12 clowns in each car, 132 clowns altogether. How many cars? Now, we could use our ratios to do this. We could say 12 clowns per one car is that's our ratio, isn't it? We're going from clowns to cars. So we would start with clowns is 132 clowns. And we're trying to find out how many cars, question mark, cars. Okay, so since I'm trying to get to cars, don't I want cars upstairs and clowns downstairs? So let's write it out. Okay, so we're going to put 132 clowns times, now we're going to turn this ratio over, 1 car per 12 clowns. Can you see how clowns will now cancel clowns, leaving me with cars, which is what I want? So I'm going to divide 132 by 12. So 132 divided by 12 is going to be 12 into 13 is 1. 1 times 12 is 12. 1 and 12. We're going to have 11 little cars. That's pretty easy. Number 2 in your problem set says, there were 35 trees on the property. 4/5 are deciduous. They lose their leaves in the fall and the winter. How many trees on the property are deciduous? So we know how many total trees we have, and we know that 4/5 of them are deciduous. So don't we want to say 4/5 of means times the 35 trees. So it's 4/5 of the total, and 35 is the total. So here, let's just make 35 into a fraction. 5 cancels. Divide that one by 5, we get a 1. 35 divided by 5, we get a 7. 4 times 7 is 28 with nothing on the bottom but ones. So 28 of those 35 trees were deciduous. Okay, number 3 says Melody weighed 7 pounds, 7 ounces at birth. How many ounces did Melody weigh? Okay, so she weighed 7 pounds and 7 ounces. So we're going to put a little plus sign in there. We already have the 7 in ounces, so we just need to find the 7 pounds in ounces. 7 pounds is how many ounces? Okay, so if you go back to page 37 where all of your units were, you can find in your little chart right here, there's your little chart on page 37, we're going to look up pounds and ounces. Okay, so right here. Okay, 16 ounces is 1 pound. Okay, so 16 ounces is 1 pound. I'm going to multiply by a ratio that's going to get me to ounces. So since I'm trying to get to ounces, I'll put ounces on the top. I'll put pounds on the bottom so it will cancel. And then I'm going to go ahead and make my ratio true. 16 ounces is 1 pound. So now pounds cancels pounds. 7 times 16. And then this is just a 1 down here. So 16 times 7 is 42. 7 plus 4 is 11. So 112 ounces. So we're going to take away the 7 pounds. And we're going to make it 112 ounces plus the 7 ounces we already had. 112 plus 7 is 119 ounces was what Melody weighed at birth. We have one more problem that I'm going to do for you. And this one is number 4. I have to get back to the right page here. Okay. And number 4 says, a bird flew 80 miles in 4 hours. 80 kilometers in 4 hours. Okay, so what was the bird's average speed in kilometers per hour? So we're trying to get to a unit rate. How many kilometers per 1 hour? Okay, so if we want to go from 4 hours to 1 hour, we're dividing by 4. So let's just divide both top and bottom by 4. 80 divided by 4 is 20, and 4 divided by 4 is 1. That bird is flying 20 kilometers per hour. I couldn't do that. Now I really am done with your lesson, and I've done 4 of your homework problems for you. So this is Mrs. A, and may God bless your day.